And welcome to today's presentations, and topic is database system architecture. We'll have a series of lectures on database management system. It refers to advanced database management systems. And today I will talk about some of the architectural trends in the distributed databases, in the database system as such. You know, they're just like the operating system. The design of databases is very much influenced by the underlying architecture on which system has been designed. So let's say, for example, you have the various characteristics or various trends of computer architectural design are reflected into design of databases. Like, say, parallelism. This is the one trend in designing of the architecture. So we have a parallel databases. We have a distributed systems. Again, we have a distributed databases also. We had a centralized system, so we have a centralized database systems. We have a network system, so client server systems are coming, and so on. So basically, if you want to understand some of the characteristics of the databases management system, advanced database management systems, you have to understand the underlying architecture of the machine. Similar things when we talk of the advanced operating systems, we talk about like distributed operating system or parallel operating systems. One has to understand the architecture of these machines now. So the today's discussions will be around these basic models. So briefly describe about the centralized systems or centralized database systems. We talk about client server systems. We talk about parallel systems, distributed systems, and network types. Briefly we will describe about all of these basic database models. Now basically, you know that we started with the von Neumann model, so we first focus on the centralized systems now. Now these are the few characteristics in this slide. We have tried to list some of the important features of a centralized systems or centralized database system, the earlier database systems now, which runs on, but right now we refer to the our whole discussion is around the books which we have written as a part of our MCA revised MCA program. Except this topic, somehow we have tried to didn't go into much detail, but somehow has been reflected at different levels now. So today we have tried to put them everything at one level, and this is what presentation is all meant for that. Now, the run on, so what are some of the characteristics of a centralized systems? Run on a single computer systems and do not interact with other computer systems, like we have a client server systems, or we have a parallel system or distributed database systems, which we'll see now. It is also called general purpose computer system or general purpose database system, where one to few CPUs might be there and a number of device controllers, which I will show you through the diagrams on a peripheral or disk driver or something like this, that are connected through a common bus that provides access to the shared memory. Just for your interest, that we have as a part of your computer architecture course or computer organizations, we have told you how to design a bus, 8-bit bus, 16-bit bus, 32-bit bus, and so on. But just for your knowledge, that bus is something, is not simply set of wires, but set of logics also. So general purpose computer system, one to few CPU and a number of device controllers that are connected through a common bus that provides access to the shared memory. Idea is that you must, when we're talking about database, also you must have an architectural background in your mind. It's not simply that you learn the SQL or you have become a database management system expert or particular database management system, but also you understand the systems which are running behind the scene, the engine which is running behind the scene. A single user systems, the earlier systems, again even now we have personal computers, but most of the systems are part of a computer network. Or workstations, desktop units, single user, usually has only one CPU or one or two hard disks. Then the OS may support only one user, and so on. Multi-user systems also, general centralized systems also come, our general purpose system also are basically categorized into two, which I will try to highlight at the later stage, that they are also multi-user systems. More disks, more memory, multiple CPUs might be, because of miniaturizations things are coming today. Multi-user operating system, multitasking operating, even multitasking is also there in single user systems also. The server serves a large number of users who are connected to the systems via terminals, often called server system. So in multi-user, what we understand that we have a one system, central system, and multiple terminals are there. They connected through a bus. Operating system is also designed as a multi-user operating system. There are large number of users are attached. Multiple memory modules might be there. Multiple CPUs might be there. Multiple more disks is also there, and so on. This is one basic model for a centralized computer systems, which is a von Neumann model. That is basic idea we had earlier, and most of the earlier programming language was designed around this architecture models. So we have a central disk controllers, printers, tape drive controller, the system bus. I was just referring to it. You have learned as a part of your organization's course how to design a bus. The CPU, there is a memory controller. This is the architectural model, and the centralized database systems or the personal computer database systems, which are earlier database, was designed around this model. Now this is basic architectural models which we have. Now then the networks started coming. You can see from this diagram that your terminal was replaced by now client now. So instead of now terminal, it become PC itself, and this has become now client server systems, where each client can work on its own because they are attached to a powerful machines, just like a server itself. Multiple clients are there. Each client generates its own request. Server system satisfy request generated at in client systems, whose general structure is shown below here. And again, we'll see at later stage that works are divided between clients and the server. There are set of tasks defined by the clients which takes place at the client side, and again something which we talk about at the server side. We'll talk about what exactly goes, like for example, transaction processing, concurrency, database recovery, security issues, interprocess synchronizations, for example. Here everything is done at the server, whereas the report generations or the graphics work, forms, everything done at the client side. So this is basically, you can see now, database functionality can be divided into two types, the backend and the front end. Backend manages access structure, query evaluations, query optimizations, concurrency control, and recovery. All these issues which we have, you might be discussing in subsequent presentation, but all have been highlighted, presented in your MCS 42. This one. In fact, the earlier semesters also we have touched upon these issues. And then we have a front end which is running, which basically done at which is called as the client side, consists of tools such as forms, report writers, graphical interface. The interface between the front end and this one is through SQL or through an applications program interface. So this is basically, we'll talk about today we have a standard interface called ODBC, or then we have a JDBC. Through this one they try to connect the client with the server. Now the advantage why we have of replacing mainframes with networks of workstations or personal computer connected to backend server machine is the better functionality for the cost, flexibility in locating resources and expanding the facilities, better user interface, easier maintenance. Server system can be broadly, so this is basic advantage of the client server systems now. Some more advantage which we will see at later stage, that because of the client server, because of the proper interface, you can connect any client with your any type of database systems, and this is what ODBC is meant for. So server system can be broadly categorized into two kinds, depending upon functionality they perform. One is sometimes called transaction servers, which are widely used in relational databases, and sometimes called data server, is used widely in the object-oriented database systems. So this is the type of functionality they do. They are called so. Now exactly what they call, sometimes they call query servers, also called query servers. I'm talking to this server system as SQL server system. Clients send requests to the server systems where the transactions are executed, results are shipped back to the client, This is one basic functionality. The requests are specified in the SQL, communicated to the server through remote procedure call mechanism. This is a way how they might communicate. Transaction RPC allows many RPC call to collectively form a transactions. Open database connectivity is a C language applications program interface, a standard has come from Microsoft for connecting to a server. Sending, so what the ODBC does, it sends SQL requests from the client side and receive results from the server side. JDBC is again extension of ODBC. In fact, first it was sitting on the top of the ODBC itself. So JDBC standard is similar to the ODBC, but it was designed for the Java. So we have a Java, then there is RDBMS engines are there, and in between JDBC interface is there. Now, the different structures are there. I will show you in the next slides what are different structure in terms of processes they perform, processes they have. They have a server processes, lock manager processes, database writer processes. So transaction server is quite complicated. So this architecturally they are different from a normal client machines. From the software point of view, from the programming point of view, they support, from the design point of view, they support multiple processes access data in shared memory. Server processes, one type of processes. What they do, basically they are multi-threaded in architecture, that you must understand. Here is the difference between a process and a thread. Thread is basically lightweight process, and today most of the programming language support the thread, most of the operating systems support the thread management. Architecture also supports the multi-threading feature. Server processes, these receive user query, execute them, send them result. This one. Most of the server which you see as a part of internet, they support the multi-threading. You make a request, otherwise they are not able to handle millions of requests. All the search engines today, they are able to have several thousand hits. How they do manage? They basically do through multi-threading. That one thread keeps on listening to the request coming from the client, receives the request, and again it passes to another thread which starts looking for, searching for, executing it, and again another thread is back to listening of a next request. So this way the management switching over is much more faster from one thread to another thread, because they all work in the same address space, whereas in the process the case is different. So processes may be multi-threaded, allowing a single process to execute several user query concurrently, typically multiple multi-threaded server processes. Lock manager processes, we'll talk about lock manager. Basically I can lock a particular column, particular page, I can lock it, particular row can be locked. So the process which does this process is called lock manager process. Database writer process, which writes the output modified by the client or by some other entity to disk continuously. Output modified buffer blocks to disk continuously. Now log writer process, server process simply adds a log record to the log record buffer. Log writer process outputs log record to a stable storage. So these are the design part of your transaction server. The checkpoint process performs periodic checkpoints. Process monitor other processes and take a recovery action if any of the other processes fail, and so on. Aborting any transactions being executed by a server process and restarting it. So these are some of the important features of this one. Now you look at this diagram. This diagram shows you the set of processes, or basically transactions server design. Basically how these processes interact with each other. You can see this is a buffer, this is a shared memory, there is a log writer process is attached to it, which writes something into the disk. There is checkpoint processes, again database writer process, lock manager process, server process. So user process might be connecting through server processes, either through JDBC or through ODBC, again which further contacts the shared memory and apply the necessary processes according to the requirement. Now this is basically what you have in this one. Now the Shared memory contains, what the shared memory contains? The buffer pool, the lock table, log buffer, cached query plans. So these all the things will be much more clearer when you go through the two important concepts of a database management systems is basically transactions, concurrency handling. These two. So if you want to understand any database, you must understand first these two things. This is above that and the transactions management or concurrency control topic, which we have discussed much more earlier in the previous semester itself. So shared memory contains shared data, buffer pool, log table, log buffer, cached query plans, reused if some query submitted again. All database processes can access shared memory. To ensure that two processes are accessing the system data structure at the same time, database systems implement mutual exclusion either through operating system semaphore or atomic instructions as a test. And you know that operating system semaphore is basically, we have discussed as a part of operating system, it is a mutual exclusions tools. Either database can pass to operating system to take control of the mutual exclusion itself. This is the way they do now, or they can handle on their own by implementing all these processes inside itself. So this is way one look at the design of a database management system. What I'm trying to explain to you is certain features between operating system and database management systems are common. So operating system, the database designer knows what architectural models they have, what operating system models they have for which they are designing the databases. So certain processes which is common between the operating system, like concurrency or deadlock handling, so they might pass it to the operating system to take care of it. But most of the operating system, they design, they take care of, like in distributed database, deadlock handling. This operating system, the database itself can, but the principles remains the same what we have learned as a part of operating system. So mutual exclusion can be supported through the semaphore. You know that in semaphore they have basically two protocols, are wait and signal, and all these wait and signals are the atomic operations. Or they can implement atomic instructions as a test and set. So this is basically how these are the inner component of your transaction server. To avoid overhead of inter-process communications for lock request and grant, each database process operated directly on the lock table data structure instead of sending requests to lock manager processes. So these are the way how they are basically work with the mutual exclusions, locks, and so on. Here is the most of the database model follow the similar model for the designing of a server, or what we call them transaction system processes. Process thread waiting for lock may either continuously scan lock table to check for a local grant, use operating system semaphore mechanism to wait on a semaphore. Semaphore identifier is recorded into the lock table. When a lock is granted, the releasing process signals the semaphore to tell the waiting process thread to proceed. It's just like the semaphore as a part of operating system, you must have implemented semaphore for let's say readers writers problems or a dining philosopher problems. Similar situations are here also. So if you can, most of these things can be implemented through the semaphore in terms of accessing or inter-process communications or mutual exclusions, because same you have a multiple transactions, they might be updating same databases. So to maintain the consistency and all this acid property, you must have some mutual exclusions type of mechanism or inter-process communications type of mechanism built into it, and that can be easily supported with the operating system semaphore concepts. And most of the database management system designer do like this. So this is something internally we are talking about, how they handle the inter-process communications, mutual exclusions, which are required for supporting concurrency and transactions handling. Lock manager process is still used for the deadlock detections. Then there is another data server which is basically used in the object-oriented database management system. Used in LANs where there is a very high speed connections between the clients and the server. The client machines are comparable in processing power to the server machines, and the tasks to be executed are computing intensive. Ships data to client machine where processing is performed and then ship the result back to the server machines. This architecture requires full back-end functionality at the clients. Used in many many object-oriented database systems. So these are the basic issues which we have: page shipping versus item shipping. Whether you shipping the, is just something, whether you shipping it, suppose that someone looks for a particular row or column, but instead of giving only page or that item, applying the principle of prefetching, they can send the complete page itself, assuming that the client might be looking for some other details from this page itself. Locking, the data caching, the lock caching. So all these mechanisms are part of the design of the server process. Now here is just little bit some details about the data server as well as just we discussed with the transaction processor. Means a smaller shipping item, smaller unit of shipping is more, will require more messages, more data transfer. That is why we don't transfer. Normal in computer network, again going back to this one, that we don't, even if normally if you working with a telnet session, now you don't simply you hitting a key that not go as a 1 byte, but it goes as a full one packet, 64 bytes might be something like this. So a smaller units of shipping require more messages, worth prefetching related item along with requested item. So these are the issues with data server designs. What should be the basic unit, a smallest unit of shipping, whether the item as page ship or page shipping, or accordingly there is a, and there is a trade-off between the two. As I told you earlier, the page shipping can be thought of as a form of prefetching. Locking, overheads of requesting and getting logs from server is high due to message delay. Can grant locks on requested and prefetched items. With page shipping, transaction is granted lock. So all those issues which we have related to the transaction server are also somehow reflected in the another database server models. Data caching, data can be cached at the client even in between transactions, but check that data is up to date before it is used. Cache coherency problems they have to do now. Check can be done when requesting logs on data item. Remember the beginning I told you that even in the client server databases, the server does much more complex job, like the concurrency or transaction handling, the cache coherence probability, consistency, all issues are handled by this one. Lock caching, logs can be retained by a client system even in between transactions. Transaction can acquire cached lock locally without contacting the server. Server calls back logs from client when it receives conflicting lock requests from different clients. So this is the issues which they deal with the data. So basically right now we defined that what is the client server systems, what is the functionalities are performed by clients, what are functionality performed by server, different type of server, this primarily two types of server, and what are the basic processes they have, also how they are basically interconnected. I showed you the diagram where we saw different type of processes are involved now. Now come to the next model, what we call them the parallel systems. So parallel systems are basically they follow the different architectural model. You know that most you understand the difference between, this is what we have discussed as a part of operating system, that you must understand the multitasking, the parallel processing, all those area you have to understand. So by parallel processing we always mean that you have more than one processors. They are basically used to scale up or to the speed up the whole operations. Something which I want to do into the which can be done on single machine 5 minutes, and I want to do into 1 minute. So again, how many systems can be added parallel, or how many of transactions can be executed in parallel, so that I can execute certain process in a smaller fraction of time. So this is basically, so parallel systems, this is basic advantage of the parallel system. Parallel system consists of multiple processes, multiple disks connected by a fast interconnect networks. It could be FDDI network, could be NTM networks. Coarse grain parallel machines, there are basically two types of parallel machines which we have, and today we are talking about massively parallel system. You can refer to your computer architecture book massively parallel system or sometimes called fine grained parallel machine. So a coarse grained parallel machine consists of a smaller number of powerful processors, a smaller number of, whereas massively parallel systems utilize thousands of smaller processors. But again, you have to interconnect with very high speed, manage them properly so that consistency problems will be maintained. Two main performance measures are throughput, this we are discussing as a part of computer network. Response time, what is the throughput here? Number of tasks that can be completed in a given time interval, number of transactions which you can process in given, in computer network parlance, number of packets which you can send them. Response time, amount of time it takes to complete a single task from time it is submitted, it is a response time. Now this is basically speed up, the two important. This way the measure the performance of your parallel system is measured. A fixed size problem executing on a small system is given to a system which is n times larger. Means basically what exactly it says, that the speed up and scale up means that something which I can do into the small time unit, that I can do. For example, same task which can be done in 5 minutes and I want to do in 1 minute. Now what extra resources are required? So basically here I am trying to refer to the speed up. A scale up is something we are dealing with very large problem, and if I want to solve it further larger, how much extra resources we have to apply to it. So speed up is a fixed size problem executing on a small system is given to a system which is n times larger, measured by a small system elapsed time taken by a small system to execute this task, and the large system same task we give to the large system, and this is the ratio. A speed up is linear if equation equals n. A scale up increase the size of both the problem and the systems, and then we see how much resources we require to do this one. Now n times larger system used to perform n times larger job, measured by a small system, a small problem elapsed time, big system, big problem elapsed time. Scale up is linear if equals 1. So this is basically we saw the speed up and and so I increase the resources, the speed up equally moves linearly. And finally we have a scale up. So these are the two basic parameters on which we try to measure the performance of this one. Now we have another, again different categories are there for the scale up, sometimes called batch scale up, sometimes say transaction scale up. A single large job typically of most database queries and scientific simulations use an n items larger per computer on n times larger problem. Sometimes say transaction scale up is more, we are more concerned with the transaction scale up. Numerous small queries, what exactly this is, to understand the meaning of this scale up. Numerous small queries submitted by independent users to a shared databases, typical transaction processing and time sharing systems. N times as many users submitting request, hence n times as many requests to an n times larger database. So this is basically well suited to a parallel executions. Now this way we basically try to understand the basic understanding which we have for our discussion is that the most of this system which we are talking about, even if the older version of database management system, they support most of the feature of database management system. Even if you talked about the database systems running on von Neumann machines for, let's say, multi-user systems, they supported some of the functionality which we have in the advanced database systems also. Like, for example, they try to do some concurrency, they do the multitasking, they try to do speed up certain operations, not in terms of, but they are not able to parallelize the operation, but each one, if a multi-user system have a multiple CPUs, then each CPU can take up single query. But when we talk of parallel systems, in terms of query handling or optimizations, it might happen that query can be optimized, same query can be distributed among large number of the CPUs. So that way we are trying to achieve the parallelism, or to increase the throughput, or to increase, or how to scale up and the speed up operations now. But some of the earlier database system also had some of these features, but in different forms. I mean, this is what I'm telling you, that if they have a multiple CPUs, but database was not able to, that was not competent enough to allow or engage all the CPU to run a single query, but they were able to run a different query. So that way also the throughput increased. But here we are trying to talk about try to different. A single CPU can also engaged, or multiple CPU might be working on a single query itself. That way we are trying to scale up and speed up. So this is basically, you can make some analogy. The point which I am trying to, I think not very clear might be, but the point which I am trying to scale up, that if you try to compare, you have to compare between the parallel database systems and the databases, client server databases, or let's say the personal databases, or you try to compare on these basic issues, that whether the query is optimized or not, whether query is parallelized or not, whether the single CPU can, whether the concurrency is properly supported or not, how the transaction is performed, whether same transaction can be run by many machines or not, and so on. This way one can understand the limitations of the old database and the advantage of this new type of things, what we are talking about as a parallel database systems. The factor limiting speed up and scale up. Of course you have, there is always trade-off here. Speed up and scale up are often sublinear due to startup costs, interference, and skew. Cost of starting up multiple processes may dominate computations time if the degree of parallelism is high. Processes accessing shared resources, system bus, disk, or logs compete with each other, thus spending time waiting for other resources. This is the problem you have. You cannot have n number of resources. Always there will be some competition for the resources, which will lead to some waiting time and so on, increase certain latencies. Increasing the degree of parallelism increases the variance in service times of parallelly executing tasks. Overall execution time determined by the slowest of parallelly executing tasks. Now what type of interconnection architectures they have? They have a bus, they have a mesh, they have a hypercube. System components send data on and receive data from a single communications bus. Does not scale well with increasing parallelism. Mesh, so this is the limitation of a bus type of system. So these all are used in advanced computer architecture, where we are not talking about one or two, we are talking about many multiple CPUs. They all are very, very fast, but is how you to interconnect. That is also a this is the basic topology they follow. Mesh topology, the hypercube, this one, and components, how the components are arranged in mesh type of topology, are arranged as a nodes in a grid, and each component is connected to all adjacent components. Components link grow with growing number of, this is the drawback with number of components. So as you increase the number of components, links also grows, and so scales better. But may require to power n hops to under root n hops to send message to a node, hops to send a message to a node, and so on. This is a hypercube system. Components are numbered in a binary. Components are connected to one another if their binary representations differ in exactly 1 bit. So this way they try to connect. You can refer to Kai Huang book, where they have shown you different type of architectural model and how the nodes are connected among themselves. Now this is the one you look at now. This is mesh architecture. This is one node. There are different nodes. All adjacent nodes are connected with each other. This is the hypercube, how they are connected among themselves. Each node is numbered in a binary form. So this is the way they are basically connected now. They use the shared memory systems. There is a shared disk system. There is a shared nothing. there is a hierarchical. These are the different type of another architectural models are there which is used in parallel database models now. And database understand and accordingly they try to perform their task now. This is again different database architectural model. Shared memory means you have a memory is not with particular CPU, a common memory are there. There are 2-3 disks. So this way all CPU basically connect a single main memory and multiple disks. This is the shared disk systems, this is shared nothing systems, and then we have a hierarchical system. So these are the different architectural model for the parallel databases now. And again each one has a drawbacks. Processor, this is the drawbacks or let's say features of shared memory. Processors and disks have access to common memory, typically via bus or through interconnections networks. Extremely efficient communication between processes because memory you can access data very fast. Downside, key architecture is not scalable beyond this one, widely used for lower degree of parallelism. Then there is a shared disk systems. You have a fault tolerance system because this can store a large data. The architecture provides a degree of fault tolerance. If a processor fails, other processor can take over its task since the database is resident on disk. So these are the ways you have. Then we have accordingly the shared nothing architecture is there, and again we have a Oracle type of systems which are using this type of hierarchical system is there, which combine the characteristics of all shared memory, shared disk, shared nothing architecture. And then you have a each node could be a shared memory systems with a few processors and so on. So this is basically, again you look at the distributed systems. Data is spread over multiple machines, also referred to as a sites or the nodes, and this is basically used to have a to meet the requirement of most of the organizations which are distributed in the nature like this. And most of these systems today the existing are basically supporting the this type of models. Networks interconnect the machines, data shared by users or multiple machines. So basically I just gave you the some features of some features of architecture of different database model, distributed system. Little bit we discuss about this one also, and mainly we discuss with the client server and the parallel databases. This one. Thank you very much.